All right, everybody, welcome back. Ready for another deep dive today?
Yeah, let's do it.
Okay, so today we're tackling a fascinating technical document all about garbage collection.
Ooh, garbage collection.
I know, right? Not the most glamorous topic you might think, but
I'd be surprised.
essential stuff. And we're specifically looking at how it works in TiDB.
One of the leading NewSQL databases out there, super popular for its ability to just handle massive amounts of data and those really high transaction volumes that you see in like real-time analytics or large-scale web applications.
Right, and so when we talk about garbage collection, in this context, we're not talking about, taking out the trash in your kitchen.
Well, kind of, but imagine it's like taking out the digital trash.
Yeah, outdated information stuff that's not needed anymore.
Exactly. And in TiDB specifically, GC is all about removing that outdated data from its storage engine. And this is actually a key part of how it manages something called MVCC. Have you heard of that?
MVCC, multi-version concurrency control, right?
You got it. It basically means the database keeps multiple versions of the data around so that different transactions can be working on their own, like, snapshots.
So they're not stepping on each other's toes.
Exactly. Prevents conflicts and keeps things running smoothly.
I can see how that would make garbage collection more important, like even more crucial, because you've got all this extra data floating around.
Oh, absolutely. You don't want to accidentally delete something that's still needed by an active transaction.
Right, that would be bad.
That's where the whole system of timestamps and safe points comes in.
Okay, yeah. I remember seeing those terms in the document. So each transaction gets a timestamp. It's kind of like a little digital receipt with the time on it.
Perfect analogy. And then that safe point is like a line in the sand. Anything older than the safe point is fair game for deletion.
So how does TiDB figure out where to draw that line? I mean, it can't just be random, can it?
No, not random at all. TiDB is actually really smart about this. It's constantly analyzing those ongoing transactions to figure out what's the oldest active one. And then the safe point is set just before that oldest transaction started.
So anything older than that is definitely not needed anymore.
Exactly. It's a really clever way to make sure nothing important gets accidentally tossed out.
Okay, that makes a lot of sense. So once we've got that safe point established, how does the actual cleanup process work? What are the steps involved in TiDB's garbage collection?
So it's a 3-step cycle: scan, delete, and then tombstone.
Tombstone. Okay, that sounds a little ominous.
It's not as spooky as it sounds, I promise.
Right, I'm listening.
So first, the system scans through all the data in its storage engine TICV, looking for anything older than that safe point we talked about. Then it deletes those outdated versions to free up space, which is great for performance. And finally, it uses these things called tombstones to mark where that deleted data used to be.
Okay, so why the tombstones? Why not just delete it and be done with it?
Good question. This is all about consistency, especially when you've got multiple transactions happening at the same time. Imagine one transaction deletes a piece of data, but another transaction is still trying to access it. Things could get messy without that tombstone as a marker.
Yeah, I could see how that would cause problems. Like the second transaction might end up reading data that's not even there anymore.
Exactly. Or even worse, it might read an outdated version, leading to all sorts of inconsistencies. The tombstone acts as a safeguard. It's like a little sign saying, hey, this data used to live here, but it's gone now.
Makes sense. So any transaction happening after the deletion sees that tombstone and knows to move along.
Precisely. It ensures everyone's working with the most up-to-date information.
Okay, so we've covered the basics of how it works, but the document also mentioned that users have some control over garbage collection. Tell me about that.
Right, you're talking about the configuration parameters. These are the knobs and dials that let you fine-tune how GC behaves.
So it's not just a one-size-fits-all kind of thing.
Not at all. There are a few key parameters you can adjust. One of the most important is TIDBREG time. This controls how long data hangs around before it's even considered garbage.
So by default, it's set to 10 minutes, right?
You got it, which works well for many applications. But let's say you're working with a system that needs to keep data around for longer, maybe for auditing purposes or something.
You could just tweak that setting and give the data a longer lifespan.
Exactly. And then there's also GC mode, which lets you choose between automatic and manual garbage collection.
Now, I'm guessing automatic is the way to go for most situations.
You would be correct. Automatic GC runs in the background, constantly keeping things tidy without you having to lift a finger.
It's like having a self-cleaning oven for your database.
I like that analogy. Now, manual GC is there if you need it, but it can be a bit disruptive to performance. It's best to avoid it in a live production environment.
It's like stopping everything to take out the crash in the middle of a dinner party. Not ideal.
Exactly. It's there if you need it for specific tasks like testing or maintenance, but generally automatic is the way to go.
Okay, cool. So let's shift gears a bit and talk about monitoring.
Hmm.
Because even with automatic GC, I imagine it's still important to keep an eye on things and make sure everything's running smoothly. What should our listeners be paying attention to when they're monitoring garbage collection in TidyB?
Great question. One of the key things to watch is the Tidberg-Hrum interval. This controls how often the system checks for garbage.
And you want to make sure that interval is set appropriately right.
Absolutely. Too frequent, and you're wasting resources on unnecessary checks. But too infrequent, and you could end up with a buildup of garbage that impacts performance.
It's all about finding that sweet spot, the Goldilocks zone for garbage collection.
I love it. The Goldilocks zone of GC. And luckily, TidyB provides some excellent built-in monitoring dashboards that give you insights into how GC is performing. You can see things like the duration of the GC cycles, the amount of data deleted, and if there are any bottlenecks.
So you can actually see how much digital trash you're taking out.
That's right. And there are also third-party tools that integrate with TidyB's monitoring system to give you even more detailed analysis.
So after spending all this time in the trenches of TidyB garbage collection, what's the big takeaway? What should our listeners really remember about all of this?
I think the biggest takeaway is that garbage collection isn't just some background process. It's absolutely vital to how well TidyB performs and how stable it is. Knowing how it works, how to configure those key settings, and how to monitor everything can make a huge difference in keeping your database happy and healthy.
It's like knowing how to take care of the engine in your car. You might not think about it all the time, but it's crucial for making sure things run smoothly. Well, there you have it, folks. A deep dive into the sometimes overlooked but always crucial world of garbage collection in TidyB. Might not be the most glamorous topic, but hopefully we've shed some light on why it matters and how it all works behind the scenes.
And who knows, maybe this will inspire some of our listeners to do their own digging into how different database systems handle this challenge. There's a whole world of garbage collection out there just waiting to be explored.
All right, everyone. Until next time, happy databasing.